In part 5 of this Python course, I will go over a collection of miscellaneous topics that I did not have the opportunity to cover in the previous 4 recordings. More specifically, there's 5 things that I would like to cover. The first one is I want to tell you a little bit about best practices whenever you're doing a coding project. Some of this is specific to Python, some of this is more generally applicable. I want to tell you a little bit about how I encourage you to structure your research project, because generally that can save you a lot of time in the long run if you spend some time thinking about that. I want to introduce you to the concept of version control, in particular using Git and GitHub. I want to show you a brief demonstration, or a brief example, I should say, of how you can use Jupyter Notebooks for multiple programming languages at the same time. And finally, I want to give you a couple of tips and tricks when it comes to trying to speed up your code in case it's taking a long time to complete. Now, best coding practices is obviously going to be a highly opinionated topic. But I think most people will agree that spending a little bit of time thinking about how we can make our code more organized and how we can make it easier to interact with is generally a good idea. In particular, if we're sharing that code with other people as well. Now, there is a paper that you can use as a starting point, which is Code and Data for the Social Sciences, a Practitioner's Guide. And it provides a good starting point. But besides highlighting important points, I don't think their practical recommendations are actually very practical at all. So what I've done is I've taken their core concepts and I've translated them into something that's actually easily applicable, and particularly if you've been following along with this Python course, because you already have most of these things in place. Now, I have 6 main coding principles. And these coding principles are not set in stone, and you just kind of can fit them into your kind of needs. But for me, the first one is that I always really strongly encourage you to be organized from the very beginning. Because the longer you wait with setting up your organizational structure, the more work it's going to be. Because at the beginning, you don't have anything. So if you set up a folder structure, it's easy. If you decide to do that midway, you have to then take everything you already did and then force it back into your structure. Second of all, I always recommend you to use version control specifically for your code and your results. I use GitHub and Git, and that's what I'll show you later on. But having that version control will, one, give you a version history so you can go back in time and show all the changes that you've done. But also, if something were to go wrong, you have the ability to roll back to a previous version, and then there is no big problem. Third, I like to use a particular flow-based folder structure. I'll show you that in a moment. Try to be descriptive. Whenever you create variables, whenever you create file names, try to make it so that someone that's not familiar with your code can get a little bit of a sense about what that contains. For file names, that generally just relates to what you're trying to accomplish in that file. And for variables, I like to sometimes include my file types in it so that I say like list something or data frame something, just so that I know later on that this is supposed to be a data frame. And I don't get confused about this. This is particularly important for Python because it doesn't force you to assign particular data types to data structures, and it will just try to dynamically infer these. So sometimes you think something is a list, but it turns out to be a dictionary, and then everything starts to break. So those are a couple of examples. I'm a big fan of using Jupyter, Jupyter Labs, Jupyter Notebooks, because it makes it easier to provide additional information as to what your thought process was, what your results are, and you cannot really get that out of a regular code file with just comments. Jupyter Notebooks are great for that. And finally, and this should be common sense, but do not do anything outside of your code. And I will call these blind spots. And a good example would be, let's say you do some code and you're working in pandas, but then you think, well, I don't really know how to do this in pandas, but I do know how to do it in Excel. So you quickly save it as an Excel file, you quickly manually do it in Excel, and then you load it back in. You're like, well, done, move on. I would strongly encourage you not to do that, even though it's very tempting sometimes. And the reason is that if you then want to change something in your code, you have that element there where you do not know what you did because it's not part of your code. It's just a manual operation that you performed. If you really have to do that, I always encourage you to use the Jupyter kind of markdown system so that you can add detailed instructions as to what exactly you did in that blind spot, so that if someone wants to reproduce it, they know exactly what to do in order to get exactly what you ended up with. Now, when it comes to coding in Python, there is a little bit of a mantra that they call Zen of Python. And it was developed by the Python developers, or at least the people that were involved, as a core fundamental thing that you can look back at whenever you're coding Python. I'm not going to go over these too much, but I think this is interesting to at some point read, which is that beautiful is better than ugly. So if something looks nice, that generally is a good idea. Explicit is better than implicit. It's best to explicitly name something rather than implicitly assume that it's obvious. Simple is better than complex. If you can do something in a simple way, it's better to do that versus a very convoluted way. And finally, complex is better than complicated. Sometimes something is complex and you cannot find your way around it. Not everything can be solved with simple solutions. But in that case, it's better for it to be complex than for it to be complicated. There are some other things. There's some things related to errors. I find this one kind of an intuitive one whenever I'm working on something, and particularly when I ask for help, which is that if the implementation is hard to explain, it's a bad idea. If the implementation is easy to explain, it's probably a good idea. And this is useful if you're working on something and you try to find help, but you Google around, you cannot find the answer. You ask someone for help, they look at you very confused. That probably is a sign that what you're trying to do does not make much sense. There's probably an easier way that seems to be a lot easier to implement and easier to explain. And the reason that people don't understand what you're trying to do is because you're doing it in such a hard to explain implementation. And finally, and this is probably the most debatable one, which is that there should be one obvious way of doing things. Now, the reason I put it in is because they do put a little bit of a caveat saying that this initial implementation might not be obvious unless you're Dutch. The reason for this is that Python was originally developed by a group of Dutch developers, and they kind of collectively came up with what they thought was the best implementations. But then people from different cultures with different kind of ways of doing things looked at some of these things and thought, why on earth they decide on that way? That doesn't seem the best way at all. And that might just be a cultural difference. So they put that in there as kind of a joke. And then there's a story here about kind of some background as to where that came from. I'm not going to go over that, but if you want to read it, feel free to pause the video. So folder structure. So that's about code. How can we write our code and try to be organized there? But how can we save our code and our data files and our output files in an organized way? Now, over the years, I've developed a folder structure that has helped me to organize my projects. And I've actually written up an article, and I have the link later on as well, and a little tool for you to set this up. But essentially, the idea is that whenever you have a project, you would have a project folder. Then you would have 4 types of folders that are in that main folder. You would have a data folder, you would have a code folder, you would have a pipeline folder, and you would have an output folder. And then within these, you would put different categories of data or code. So your data folder will have all of the data that you start with, the raw data. The data that you did not manipulate, the data that you downloaded from a data provider, or the data that you've manually collected, whatever. You would put that in there, and then I'd like to split it up into either external information or manually collected information. A key kind of principle here is that anything you put in here, anything you put in this data folder, you should never modify. And the reason that that's important is because if you download some data from Compustat, you always want to still have that raw data file there. You don't want to manipulate that and then lose the original file, because then you might not be able to reproduce what you did because you don't have the starting point anymore. Then you would have your code folder, and in your code folder is where all your different code files will go. I like to name my code files with a number to indicate the order of execution, and then some brief description of what it's supposed to do. And then this is kind of the most innovative part, the most distinct part of this setup, is that I like to use a pipeline folder. The pipeline folder is the folder that you use to store files that you've generated in your code. And those files can then be loaded on by future code files. But I'm making a distinction between the original data, the 0 data, and the data that I've generated using my code. So for example, if I were to have a code file, and this code file is called 0 load data, then what I would do is I would create, and I do this automatically, I would create a folder in my pipeline folder that has the exact same name as that code file, 0 load data. And then within that folder, I would always have 3 folders, which is the out folder, which is the kind of the final product of that piece of code. I would have a store folder. That's whenever I want to just store some information, because sometimes code takes a long time to run and I want to just save some intermediate steps so I don't have to wait every time. I would start it there. And then anytime I want to just quickly save something for the purposes of inspection or whatever, I would save it into the temp folder. And then the core idea would be that whenever I save anything in the load data code file, I would only save it to the respective pipeline folder so that I know anything that's in this pipeline folder was created in this code file. And whenever I load data, I will either load data from the zero data folder, or I will load it from the out folder of one of the previous pipeline folders. And then that's useful because then whenever I see something being loaded out of a pipeline folder, because of the fact that the name of that folder is the same as the code file that generated it, I immediately know, without having to put any comments or anything, I immediately know where that code or where that data was generated and where the code lives if I wanted to check it out and see exactly what happened. And then finally, I would have an output folder, which is probably the least important one, where if you were to generate tables or if you want to generate graphs or whatever, I would put those in the final output folder, and then I would put those into my paper. And then I would always set my working directory to this highest level project folder so that irrespective of the computer I'm using, as long as my working directory is right here on this project folder, I know where to go and my code will just run because everything is dynamically linked and it's always set up in the same structure. So I like to use this a lot. I've written an article in the end of 2018 with a lot of details, a lot more details about how I would go about doing this. If you click on this picture here, it will open it up for you. And I've also created a little tool, a little website, a little web app that you can use whenever you start a new project, because as I mentioned, I always recommend you to start with the structure from the very beginning. But if that takes a lot of time, then you're not going to do it. So that's also the problem I faced. So I wrote a little script and I put it on my website. So then you can give it the name of your project. You can give some options. And then you just click download folder structure. It will give you a zip file. You put that zip file somewhere, and then you already have all of this folder structure set up. And it also includes template files for Python, Stata, and R that has all the logic in there so that you don't have to recreate these folders automatically or manually, and it will do all of that automatically for you. Version control. Now, version control is by no means specific to Python, but irrespective of the type of code that you're writing, I very strongly encourage you to go and look into version control. I use version control for everything, and I almost would say I use it religiously simply because it gives me a lot of peace of mind. So version control is a system that allows you to record changes that you've made to code, and it allows you to reverse back to previous versions of your code up to the very beginning when you started tracking it. And why do you need it? Well, if your project folder ever looks like something like this, for example, where you have code and then you have different versions and different dates and old and backup and whatever, this is probably an indication that you should go into version control, because version control will allow you to just have one version of a file on your drive. But if you want to look at previous versions, you just go into GitHub, for example, you can pull up the previous version. Now, there technically are multiple ways of doing version control. The primary way that people have settled on is using Git. And Git is great. I have a little bit of a comic here. The kind of running joke with Git is that the commands can be very hard to use, but generally speaking, as long as everything works as it works, it's kind of easy. And if it stops working, you just delete the thing, clone back the most recent version, and then add any changes to that and then try again. And generally that will solve your problem. So that's a little bit of a running joke that's displayed here. Now, how we can use version control, as I mentioned, I recommend to use Git. And then more specifically, I recommend you to use GitHub. There's a couple other providers as well that you can use, Bitbucket and GitLab most notably. For our intents and purposes, I would only go for GitHub because it's, one, the most widely used. It has a lot of good features. The free version is great. So you really don't have any reason to use any of the other two. But just know that they exist in case you were to run into problems, or in case someone else is using Bitbucket or GitLab, for example. Just know that the logic is largely the same. It's just a different website and a different kind of software suite. So what is GitHub? GitHub is a website, and it's a website that can interact with your Git so that whenever you make changes, you can look up previous changes on the website. And the reason that this is important is because while having a version history is one thing, having a version history that's easily accessible is maybe even more important. Because if you have an obscure file somewhere and you do have it saved, but it's extremely tedious to open it up, then it's not really doing you any good. So GitHub tries to solve this problem by giving you a web interface so that you can interact with your version history. It has native support for rendering Jupyter Notebooks. So if you put Jupyter Notebooks into GitHub and you click on them, you will actually see the rendered version and not the underlying code. The GitHub desktop application is very good, so you don't have to use the command line. And finally, it has free unlimited private repositories. It used to be that you would have to apply for this as an academic, but nowadays it's free for everyone. So that kind of saves you that step. And finally, you can also use it to host websites, which my personal website is hosted on GitHub, for example. If you want to look into that, you can look into GitHub pages. It's a really awesome service and it's worthy of a mention. You can still apply for a special GitHub education account that will give you all the features. Initially, you would only do that to get private repositories. Private repositories are free for everyone nowadays, but you can still apply for GitHub education. So I put the link here in case you still want to do that. Now, the basic workflow that I would do whenever I use version control is I would first, and this is important that you start with this, I would first start with creating an empty repository on GitHub. So you go to GitHub, you'd say create new repository, you'd say public or private, and then you would start with that. And the reason that that's important to do first, because then you can clone that and you can put your data in it instead of having to do that merging thing, which can be a little tedious. So you open it up in GitHub, you create your repository, then you use the GitHub desktop software to clone that onto your own computer. Then you would take your project contents, and if you haven't done anything yet, then it's not going to be anything. But if you already have some code, you would take your project content, you would copy paste that into the new folder that you've just created. You would set up a git ignore file so that you can automatically determine what you do or do not want to be sent to GitHub. Generally speaking, you don't want to submit credentials or passwords or anything else to GitHub because that would be a security hazard. And then whenever you start working, you open up your GitHub desktop client, you click sync. You do this before you start working just to make sure that everything's up to date. This is particularly important if you work with multiple people because you want to pull in any changes that they've made so that you don't get any version conflicts. And then when you make changes, and I would generally do this at the end of a work session or at the end of the day, I would go back into GitHub. I would again click sync just to make sure that there's no conflicts. I would create a commit. And a commit is just you saying, hey, I want to record a new set of changes. You can give it a name. And then once you've created that new set of changes, it will automatically calculate what changed and all of that. And then you just click push. You click push and push will send it to GitHub. If you don't do that push step, then you have created a new kind of start that indicates that you've made changes, but you haven't actually pushed it to GitHub. So you want to make sure that you don't forget that push step because otherwise it doesn't show up on GitHub. And then the git ignore file, you can usually start with a template. GitHub provides templates. You can find templates on the internet, but you want to exclude certain things from being uploaded to GitHub, as I mentioned, credentials, but also data, because GitHub is not designed to store large amounts of data. You're better off doing that on Dropbox or something, but GitHub is really meant for code and results. So you want to make sure that any data is not being sent to GitHub because then you will run out of drive space there and then that will cause you all sorts of problems. So you can automatically do that in git ignore, and any byproduct files, any temporary files or log files or anything you don't really care about, you can exclude those as well. The git ignore file is a file where you can specify what you do or do not want to send over. The syntax documentation is linked right here, and I have an example here how I would usually do it. I like to start with putting these little symbols right here just so that if I do this, then anything will automatically be ignored because I'm essentially saying ignore everything, but then I am telling it what not to ignore. And because I often have more files that I want to ignore than that I want to get through, so it's easier for me to say that I want to ignore everything and then tell it that I want to get the code and I want to get some paper data, LaTeX, for example, and in my git ignore file, and then just so that those files do get through, but anything else does not get through, and that generally saves me some time. But you can do it the other way around as well. Just look it up on the internet. Okay, so I want to wrap this up by showing you a couple of, let's say, cool things that you can do with Jupyter Notebooks and Python. The first thing is whenever you use Jupyter Notebooks, you're not constrained to just using Python. More specifically, you can even use multiple languages within one Jupyter Notebook, which is a personal favorite of mine. And there's a whole bunch of supported languages. You have Python, obviously. You have R, Stata, using my own IPyStata package. There is some support for SAS, but I've never tried it, so I'm not able to vouch for it, and many, many more. There's a full list of kernels here. And you could also use multiple ones, and you would use these magics that I've talked about. Just look up any of these. If you look up, for example, my IPyStata package, you'll see some examples of how this would look like. If you want to see how this would look like, you can also look up one of these repositories, such as my IPyStata repository. It will show you some examples. or you can look up the demonstration recording that I'll make after this, where I'll also demonstrate to you how that would look like for Stata in particular. Now, finally, sometimes you wrote some Python code and it's very slow. It takes a lot of time to run. This is generally the case if you want to loop and you have to loop over a lot of different files, for example. There's two things that you could do in that particular case, and this can be useful in particular if your project is somewhat time constrained and you really have to get it done, which is that one, you could consider trying to see if you have a compute cluster at your institution that you can use in order to execute your code there. Those tend to be more powerful machines that can run for extended periods of time without you having to worry about you using your computer or whatever. So I'd recommend to look into those. And you can even, if you set it up in certain ways, you can even work with your Jupyter notebooks on your local computer, but then connect it to a Jupyter server that's running on a remote system. That takes some time to set up. But nowadays, there's even services where you just get a Jupyter notebook and you don't need to deal with setting anything up, and you just run your code and then you pay some money in order to run that. All these different opportunities, if you're interested, make sure you look that up. And finally, if you don't have the ability to run it elsewhere, or if that even doesn't solve your speed problem, you might also want to look into parallelization or multiprocessing. Because a computer generally has multiple cores, and by default, Python will just execute your code on one core. So let's say you have a very powerful system, you have 6, 8, or 12, or even more cores, then you might be able to use the joblib library in order to execute your code at all of your different cores that you have at your disposal. And that might sometimes speed up your code by 4 or 5 or 6 or even more times, depending on the amount of cores that you have available to you. If you want to look into that, just look into the joblib package. There's great documentation, so you should be able to figure that out. And with that, that wraps up the 5th and final recording. The next steps, I would say, look up the demonstration recording. That's where I'll demonstrate some of these things in code. And when it comes to problems, I don't have the problem notebook right here, but what you can do is if you look up on GitHub, you will be able to find a markdown file that gives you some steps that you can go through, particularly when it comes to version control and trying to set up a GitHub repository and send some data to it.